Welcome to MyProjectBazaar.com. Let me discuss about the project detection and classification of OFDM waveforms using Cepstral analysis. Let me discuss about the abstract of the project. Cepstral can reveal periodicities in a signal and has been widely used in audio and speech processing applications. In this process, the distribution of the Cepstral coefficients of OFDM signals in additive weight Gaussian noise channel are derived analytically. Problem of finding ideal spectrum is modeled as a statistical hypothesis testing problem. For solving such a problem, two local detection algorithms based on Cepstral analysis for detecting OFDM signals are proposed. Furthermore, Cepstral-based algorithms for estimating the data length and cyclic prefix length of an OFDM signals are proposed. Here, the Cepstral signals are analyzed based on the AWGN noise. The Cepstral signals are analyzed without AWGN and also considering the AWGN noise at the channel. After that, finally, we estimated the data length over the OFDM channel. Let me discuss about the flow diagram for our process. Initially, we have to generate the OFDM signal based on the OFDM generation. So, OFDM signal generation, and OFDM signal consists of a sum of subcarriers that are typically modulated by a using phase shift keying or quadrature amplitude modulation. If this number of subcarriers, then symbols are fed to the IDFT in an OFDM transmitter. The symbols along IDFT output forms the data part of one OFDM symbol. The random and complex QAM symbols, then the output of the IDFT is given by a solution. A complete OFDM symbol is then created by adding a CP by copying lost samples of the data part in front of the symbol. In the transmitted OFDM block contains OFDM symbol each of samples, then the total number of discrete time samples in the transmitted OFDM signal. Next, the creation of coefficient for OFDM signal. In the Cepstral creation of OFDM signal, the Cepstral coefficients of AWGN and also Cepstral coefficient for OFDM signals are distributed. The received signal contains only AWGN samples. Is the noise variance. After taking DFT, the unitary transform, the distribution remains the same. Since x of k is a zero mean complex circular Gaussian random variable with variance circular log Rayleigh distribution. Here the presence of AWGN only considered. The probability density function for circular log Rayleigh random variable is derived, and log Rayleigh distribution is characterized by a property that all its central moments of order higher than 1 are independent of localization parameter. Next, in the distribution of Cepstral coefficient for OFDM signal, here the OFDM signals are taken, and with the help of OFDM signal we have to derive the PDF of an OFDM signal, that is probability density function. After taking the mean and variance of the Z of k, we have to perform the IDFT operation of the Z of k. Finally, we obtain the Cepstral coefficient. Next, the detection of OFDM signal based on Cepstral coefficients are analyzed. Once we obtain the distribution of Cepstral coefficient for AWGN and also the Cepstral coefficient for OFDM signal, we have to calculate the detection of OFDM signal based on the analyzed Cepstral coefficients. In this section, we uncorrelated the S of n and also W of n, and we have to derive the detection of OFDM signal based on the above estimated Cepstral coefficient. With the above estimated Cepstral coefficient, we can easily obtain the detection of OFDM signal. Finally, the subsystem based detection algorithm is formed by a binary hypothesis test where the null hypothesis represents the received signal contains only AFWGN, while the alternative hypothesis means that the OFDM transmission is active. Finally, we estimate the probability of detection in the performance analysis part. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click that file and run for executing this process. Here we derive the OFDM waveform, and then we have to calculate the Cepstral signal based on the OFDM signal and also based on the AWGN noise. After that, we have to detect the Cepstral OFDM signal in the based on the Cepstral coefficient. Here we obtain the output. This is the input signal, received signal contains only AWGN, and this is the Cepstral signal for AWGN noise. This is the received OFDM signal. We have to generate the OFDM signal. This is the Cepstral signal for OFDM signal, and this is the simulated and analytic distribution for AWGN noise, and simulated and analytic distribution for OFDM in AWGN. And this is the analytical and simulated mean values of real part of Cepstral coefficient. And here the analytical and simulated mean values of OFDM signal. And this is the probability of detection curves for the proposed Cepstral based schemes. Here the C of 0 represents the considering the AWG noise only, and the C of ND is the Cepstral coefficient for OFDM signal. Of the detection curves for the proposed Cepstral based schemes. Here the graph plotted between AWGN and also OFDM signal, and here probability detection curves for the proposed Cepstral based scheme. Here the considering Cepstral coefficient under AWGN also and OFDM signal. Here we obtain the probability of detection curves for proposed Cepstral based scheme. Here both LTE and also WLAN application are proposed. Here probability of detection curves for the proposed Cepstral based scheme. Here single user, 5 user and also 10 users for both OFDM and also AWGN noise. Here the mean of the NC value, that is mean of the OFDM signal, has been estimated. Variance of the NC value obtained. Mean of the ND value, mean of the IDFT value, and variance of the number of OFDM value signal. And this is the probability of detection curve between AWGN and also OFDM signal, and this is the probability of detection curves between AWGN simulated result and also OFDM simulated result. This is the probability of detection curve for one number of users between OFDM and AWGN noise signal. Finally, we obtain the detection of OFDM signal based on the Cepstral coefficient. Here we estimated the Cepstral coefficient under AWGN noise and also OFDM signal. Thank you.